Good morning, everyone. In the previous class, we were discussing about the Chomsky hierarchy. So, according to Chomsky hierarchy, we have categorized the grammars. We have discussed types of grammars. So, let us begin with our type 1 grammar. That is type 0 first category. That is type 0 grammar. So as we all know, grammar. So grammar is a quadruple, right? So any grammar, type 0, type 1, type 2, type 3, type 4, any type of a grammar you take, so it has a common definition, it's a quadruple. So grammar is V, T, P, S. So V stands for set of non-terminals, T stands for set of terminals, P stands for set of productions, and S stands for start symbol. So this grammar is general for all categories of types. So a grammar is said to be type 0 grammar, or it is also called as unrestricted grammar, or it is also called as phrase constructed or phrase structured grammar. This is called as unrestricted or phrase structured. It's called as unrestricted or phrase structured. So, if a grammar is said to be type 0 grammar, then the productions within that will be alpha tends beta. Alpha tends beta. So, all the productions, if alpha tends to beta exist in your grammar, it is said to be unrestricted phrase or a phrase structured grammar if alpha belongs to V, U, T plus and beta belongs to V, U, T star. V, U, T star. And in this type of grammar, there is not at all any restrictions for the length of alpha and length of beta. The only restriction behind this particular grammar is that alpha should not be epsilon. Alpha should not be epsilon. So ಅದು ಒಂದು ಬಿಟ್ರೆ ಈ ಟೈಪ್ ಆಫ್ ಗ್ರಾಮರ್ ನಾವು ಟೈಪ್ 0 ಅಂತ ಗ್ರಾಮರ್ ಕರೀತೀವಿ. ಅದು ಒಂದೇ ರೆಸ್ಟ್ರಿಕ್ಷನ್ಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಅನ್ರೆಸ್ಟ್ರಿಕ್ಟೆಡ್. ಲೆಂತ್ ಯಾವಾಗಲೂ ಆಲ್ಫಾ ಲೆಂತ್ ಎಷ್ಟು ಬೇಕಾದ್ರೂ ಇರಬಹುದು, ಬೀಟಾ ಲೆಂತ್ ಎಷ್ಟು ಬೇಕಾದ್ರೂ ಇರಬಹುದು, ರೈಟ್? ಸೊ ಇದಕ್ಕೆ ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ನಾವು ತಗೊಳ್ಳೋದಾದ್ರೆ, ಈ ತರದ ಅನ್ರೆಸ್ಟ್ರಿಕ್ಟೆಡ್ ಅಥವಾ ಫ್ರೇಸ್ ಸ್ಟ್ರಕ್ಚರ್ ಗೆ ನಾವು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋದಾದ್ರೆ, ವಿ ಕಾಲ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಆಸ್ ಟ್ಯೂರಿಂಗ್ machine. So this Turing machine we will be studying in our next module. So Turing machine is an example for your type 0 grammar, and this type 0 grammar is recursively enumerable. It is recursively enumerable. So example or productions for your Turing machines can be simple example for your Turing machine. So S tends to A, B, or epsilon, and A tends to AA tends to BAA, and BA tends to yes. Sorry, not F, it's A. BA tends to A. Right? There is no restriction. So only restriction is this part should not have your epsilon. Other than that, you can have any length. So in single use ಮಾಡಿದ್ರೆ double use ಮಾಡಿರಿ. ಅದೇ ತರ 4 use ಮಾಡಬಹುದು, 5 use ಮಾಡಬಹುದು. There is no restriction on the length on the alpha and beta. The only restriction is alpha should not belong to epsilon. And this type of grammar, what we are seeing here, we call it as type 0 grammar. Clear with this? Okay. Next we'll move on to type 1 grammar. So type 1 grammar again, it is a type grammar which has a quadruple So this grammar is said to be type 1 grammar, or it is also called as context sensitive grammar. If all the productions are, alright, it is also called as context sensitive. Context sensitive grammar if all the productions are of the type alpha tends to beta, but there is a restriction on length of your beta. So all the particular things of the properties of a type 0 grammar will belong to this type 1 grammar. So type 1 grammar is a grammar of quadruple BTPS. It is called as context sensitive grammar, and if all the productions are alpha tends to beta and alpha belongs to, again it is VU T plus and beta belongs to VU T star, where again here condition exists. Adu unrestricted ittu. Here restrictions is that. Here restrictions ಏನು ಇರಬೇಕು on the length of beta. Beta length should be defined basically. So beta length ಏನಾಗಿರಬೇಕು ಇಲ್ಲಿ? So the constraint over this particular length of the beta is that beta should be either equal to or greater than your alpha. So beta should be equal to or greater than to the length of your alpha. So length of the alpha should be less compared to length of the beta. That is the only constraint for your type 1 grammar. Clear with this? This type 1 grammar are used in the applications of linear bounded automata, which are constructed to linear bounded automata use ಮಾಡ್ತಾರೆ. So linear bounded automata are constructed to recognize the language generated from the grammar. So ಯಾವ language generate ಆಗಿದೆ ಅಂತ ಐಡೆಂಟಿಫೈ ಮಾಡಕ್ಕೆ ಈ particular linear bounded grammar ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, right? So ಈ linear bounded grammar ಹೇಗಿರುತ್ತೆ ಅದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ, just see this. I'll write here S tends to AAB, capital letter B, AA tends to BAA, and BA tends to AA, right? So you can clearly make sure that the length of alpha is this, right? This is alpha. The length of the alpha is less than or equal to the length of the beta. Is less than or equal to the length of the beta. That is the only constraint for your type 1 grammar. And this type 1 grammar are usually used where? In the linear bounded applications. In the linear bounded applications, you are going to use your type 1 grammar. Clear with this? Okay. We'll move on to next type of the grammar. Next is type 2 grammar. The type 2 grammar, again a grammar G with a quadruple BTPS, is also called as context-free grammar. Is also called as context-free grammar. Is also called as context-free grammar. And the grammar with a quadruple GVTPS or context-free grammar are said to be type 2 grammar if all the productions with your grammar are in the form A tends to alpha. A tends to alpha, where alpha belongs to V, U, T plus, and A is a non-terminal. A is tends to non-terminal. So ಇದರ ಅರ್ಥ ಏನು? So productions in your context-free grammar or type 2 grammar, in the left hand side should have your non-terminal. ಇಲ್ಲಿ non-terminal ಇರಬೇಕು. So in the previous grammar ನಾನು ಏನು ಯೂಸ್ ಮಾಡಿದೆ, AK ಅಂತ ಯೂಸ್ ಮಾಡಿದೆ. ಒಂದು non-terminal, ಒಂದು terminal ಯೂಸ್ ಮಾಡಿದೆ. But ಅದು type 2 ಆಗಲ್ಲ. Type 1 ಅಥವಾ type 0 ಆಗುತ್ತೆ. Whereas in a context-free grammar, in a type 2 grammar, all the productions in the left hand side should be non-terminals only. It should be non-terminals only. Clear with this? So whereas in the right hand side here, this right hand side, you can have epsilon, terminal or non-terminal combinations. You can have terminal, non-terminal combinations. Okay, example for this particular type 2 grammar, I'll write just a small productions. I'll be writing S tends to A, B or B, A or epsilon, and A tends to A or B, B tends to B, B or A. Or you can have your epsilon here, epsilon here. See, in this grammar, all the symbols on your excuse me, left hand side are non-terminals. So non-terminals is all the uppercase letters, right? So terminals and non-terminals beginning definition right? So all the non-terminals are capital letters. So in the terminal side, in the right hand side, you can have a combination of terminal and a non-terminal, or you can also have epsilon. So any type of productions with this particular form, that thing we can call it as type 2 grammar. Clear with this? Okay. Next is type 3 grammar. And this particular type 2 grammar is called as context-free grammar. This context-free grammar are used in the applications of push-down automata. It is used in push-down automata. It is used in push-down automata. Next is type 3 grammar, and the last type of the grammar. So type 3 grammar, again it is a grammar with a quadruple G equals to BTPS. And this any grammar is said to be type 3 grammar, or it is also called as regular grammar. It is also called as regular grammar. Any grammar with a quadruple is said to be type 3 grammar or regular grammar if they have the productions of the form A tends to WB or A tends to W. A tends to W, where A and B are the variables and W belongs to T star, where A and B are variables. So variables are non-terminals. They are variables or non-terminals, and W belongs to T star. What is this T star then? So T star is nothing but set of or a string of terminals. String of terminals. String of terminals. Right? So it can have a string of terminals. That is, it can also have epsilon because T star is there. So one or more occurrence. Irbodu, irdene, irbodu. Right? So context-free grammar and regular grammar are almost same. Where in your regular grammar you can have a set of strings written, right? So example for that is S tends to AA, B and BB, A or epsilon, and A tends to AA, small b, and b tends to bb and a epsilon. Right? So, in observation in so in the previous grammar we have only one symbol. So here we have a set of strings. So set of strings of a terminals. Adu terminal string ge agirbeku. So terminal string ಆದ್ಮೇಲೆ ನಮಗೆ ಈಗ ನಾನ್ ಟರ್ಮಿನಲ್ ಬರಬಹುದು. That is type 3 grammar. Clear with this? So these are the different types of grammars, and this is quite important for your examination. Please consider this very important, and all of you study correctly. Okay, thank you. And the next in the next class we'll be moving with the finite conversion of finite automata to a grammar. There, thank you.